Okay guys, let us continue. Now I want us to look at question 2.1.3. Again, we are still solving for x, but now we have an inequality. So how to go about doing this? Again, you have the quadratic equation, so we can factorize this, or if you can't factorize, you can also use the quadratic formula, but I'm going to use factorization. The equation is already, the inequality is already in standard form, in a form of ax squared plus bx plus c. So let us factorize here. The factors of x squared, it's x and x. Now we want the factors of 10. Singathi maswa subtract asinikeze positive 3. So obviously 10 is the same as 10 times 1. It is the same as 5 times 2, but we want the factors. This would maswa subtract asinikeze bani positive 3 noma asinikeze 3. So now should between these two we are born now finally start 5 and 2. So we put 5 here and 2 here, but remember we want to have positive 3. So if we have 5 and 2 and want to have positive 3, that means 2 must be negative. So that is why I'm going to put negative this side and positive 5. Alright, and another method that you can use to check if your answers are indeed, your factors are correct, you can just multiply, we used to call it inners. So 5 times x, that is 5x, and you also multiply the outers. When you multiply this, it's x times minus 2, your answer will be minus 2x. Then when you say, like terms now, 5x minus 2x, your answer is 3x. That is also another method that you can use to do what? To check which factors are correct here. Now, one thing that is important here now is that we no longer have the equal sign here. So we want the values of x that will always make this to be less than 0, not equal to 0 now. So that is why we are not going to say x is equal to minus 5 or x equal to 2, because if x is equal to minus 5, if you substitute it here, it is going to give you 0. The moment you have 0 here, everything is going to be equal to 0, and you're going to end up having something like this, which is 0 less than 0. That doesn't make sense. We can't have something like that. So these solutions here, we now have to indicate that these are what? These are critical values if you want to show them. Sometimes I even encourage people not to even show them, because you might end up forgetting to write that these are critical values, and then Google my answers are correct. So the critical values, but now here we want values that are values of x that will make this thing to be less than 0. So well, it's up to you here, but remember this question, to those that have done functions, is a question that is similar to equation 80, for which values of x, for which value or values of x is f of x less than 0. So there is a great link between functions and this type of a question. That is why ngithanda kakhulu ukuthi mangenza lento we use what? The graph. Now this graph, these are your x-axis. It's like we are drawing just a small graph or just a demo of a graph here. If I were to draw or sketch this graph, it was going to have these x-intercepts, -5 and what, and 2, and sometimes you even indicate that this -5 is not included and this 2 is not included with those open circles. Now looking at this here, very important again, since we said there's a great link between this question and what, and ama functions akho. Now this is a quadratic function, this is a parabola, so the value of a here, is positive. If we were to draw this graph, it was going to have a shape like this. It is concave up. But now we want the values of x where the graph is negative, or where the graph is less than 0. Obviously you know that above the x-axis you have positive what, y values, and below the x-axis you have negative what, y values. So which one are we looking for at this moment? We are looking where the values of y are what, are negative. So the values of y are negative below the x-axis. So this is the region that we are looking for. So we are basically saying now, if you want this equation to be always less than 0, that means you need to take the values of x that are between 2 and -5. Obviously the values of x that are this side, they are less than 2, and the values of x that are this side, they are greater than -5. So this is one method in which you can solve this equation. Now let me maybe repeat this one. What is it that is important? Number one, you will have to factorize. You will have to factorize. After factorizing, you get what? The critical values. If you want to show them, please don't forget to indicate that these are the critical values. Then number three, you can either use your graph, or you can use, others use what, number line, or others use what, a table to get the solution to this type of an answer. And then after that, you interpret your answer using this sign that you have here. In this case, our sign was negative, meaning we were looking for the values of y that are what, that are negative, and the values of y that are negative are below the x-axis. So looking at this graph, if I take a value of x here, it will correspond with the negative y value. If I take the value of x here, it will correspond with the negative value of y. So we can't then write all these answers one by one, so we are just grouping them with this statement here, which if you take any value that is between 2 and -2, you are going to get a negative answer here. If we have time, you can maybe take any value. You can take 0 and put it here. If you put it 0, definitely your answer on the left hand side is going to be negative or less than 0. I hope you understand. Please take some time, look at this one, listen, pause, rewind, so that you understand it better. This is one of the questions that normally give learners a challenge. Okay, I hope I tried to make it clear. If you do not understand, please make notes so that on Saturday when we meet, you can ask my questions. All right, thank you so much.